1 week ago, 14 states set all-time March temperature records, 112 degrees Fahrenheit. Wildfires burned 600,000 acres in Nebraska, the worst in state history. The National Weather Service used language they said was not typically seen in March. Today, 57,000 people have lost power to an ice storm. Blizzard conditions are burying Minnesota, and tomorrow, a tornado threat is targeting 3 of Ohio's largest cities. Same country, same week. One storm system is producing tornadoes, ice storms, blizzards, flash floods, and baseball-sized hail simultaneously across 20 states. That is not normal. That is not even close to normal. The atmosphere just flipped from the worst fire weather emergency in March history to the worst compound weather disaster of 2026 in 5 days flat. Stay with me, because what is driving this is far more unsettling than the storm itself. If you genuinely enjoy what I do here, make sure to hit like and subscribe so you do not miss a single update as this story continues to unfold. Drop a comment with where you are watching from, what time it is there, and what the weather looks like outside your window right now. Because depending on where you are, it could be anything from 70 degrees to an ice storm. Now, get comfortable and let's dive in. Part 1. The Snapshot. 296. That is the number of weather alerts active across the United States right now. As of April 4th, 2026, at 7:43 UTC, 296 separate warnings, watches, and advisories are flashing across the national map. Let that number settle in for a moment, because the number alone does not tell you what makes this extraordinary. What makes this extraordinary is what those alerts contain. Ice storm warnings, 8 of them, blanketing Michigan's Upper Peninsula and northern Wisconsin with 1/4 to 1/3 of an inch of ice on power lines and trees. Winter storm warnings, 18 of them, stretching across Minnesota and North Dakota, where 6 to 9 inches of snow are falling, with 40-mile-per-hour winds and visibility below 1/4 mile. Flash flood warnings in Ohio, where 2 to 3 inches of rain have turned roads into rivers. Severe thunderstorm watches covering Missouri, Arkansas, and Oklahoma. And tomorrow, the Storm Prediction Center has a tornado risk across the Ohio corridor, with the possibility of a strong tornado near Columbus, Cincinnati, or Cleveland. This is not 5 separate weather events. Read that again if you need to, because it is the single most important sentence in this entire video. This is not 5 separate weather events. This is one storm system, one single low-pressure center and its trailing cold front, doing 5 catastrophically different things to 5 different parts of the country at the same time. Tornadoes to the south, ice to the north, blizzards to the west, flooding in the middle, and severe thunderstorms pushing east toward the coast. This is day 4 of a 5-day severe weather disaster that has already produced an estimated dozen tornadoes, over 150,000 power outages, a flash flood emergency with 4 feet of standing water in Ithaca, New York, baseball-sized hail in Iowa, 2 confirmed deaths in Indiana, and hundreds of severe weather reports from Texas to Michigan. 4 days, 1 system, and it is still going. But here is where the story turns from severe to surreal. 14 states broke all-time March temperature records this year. The national March record was shattered at 112 degrees Fahrenheit, 112 in March. Relative humidity dropped to 8% across the high plains. Wyoming was shutting off power lines to prevent wildfire ignition. The SPC issued a critical fire weather risk using language the National Weather Service described as not typically seen in March. That was 5 days ago. 5 days ago, this country was on fire. Today, it is buried in ice. The boundary between seasons has collapsed, and the data says it is not coming back. Over the next few minutes, we are going to walk through this disaster day by day. We are going to trace the atmospheric mechanics that made it possible, the jet stream amplification, the ENSO transition, the 3 sudden stratospheric warming events that broke the polar vortex, and the record ocean temperatures that are pumping energy into every storm system on the planet. We are going to look at the conspiracy theories, because there are plenty of them circulating right now, and we are going to look at the extended forecast, because if you think this week has been bad, wait until you see what the Weather Prediction Center is projecting for next week. Let us get into it. Day 1, April 1st. April 1st, 2026. A surface low deepens over the Central Plains, and the Storm Prediction Center issues an enhanced risk across portions of the Midwest. The atmospheric ingredients are textbook severe weather: 3,000 joules per kilogram of convective available potential energy, a 45-knot low-level jet, and a sharp cold front racing east. For anyone who does not speak meteorology, that translates to this: the atmosphere is loaded with explosive energy, the wind structure is configured perfectly for rotating storms, and the cold front is the match that lights the fuse. The first supercells fire across Iowa, Illinois, and Missouri in the late afternoon. Quasi-linear convective systems, essentially walls of thunderstorms moving as a single organized unit, follow behind them. These QLCS structures are dangerous for a specific reason. They produce widespread damaging winds across a broad area, and they can spin up brief, embedded tornadoes with almost no warning time. You do not see them coming the way you see a classic supercell tornado. They form inside the line, touch down, and lift in minutes. The after-dark timing compounds the danger. By the time the strongest storms reach peak intensity, most of the affected population is asleep. Warning response rates drop dramatically at night. You cannot see the storm, you cannot hear the sirens if you're inside, and the tornado warnings are going to phones that may be on silent. Near Kelowna, Iowa, a confirmed tornado is detected on radar. Not just rotation, but a debris ball signature. A debris ball means the radar is picking up physical objects being lofted into the atmosphere. Pieces of buildings, trees, vehicles. That is not a signature of wind. That is a signature of destruction already in progress. In Cleveland, 75-mile-per-hour mesovortex winds rip through neighborhoods. A mesovortex is a spinning pocket of wind embedded within a larger storm line. It is not classified as a tornado, but at 75 miles per hour it does not matter what you call it. It is flipping cars, it is tearing roofs off houses, it is turning debris into projectiles. Over 150,000 customers lose power across Ohio and Indiana in a single night. First responders are overwhelmed. Damage reports are stacking up faster than dispatchers can process them. The storm is moving fast, 40 to 50 miles per hour, which means any given location has only minutes between the first gust and the worst of it. By the end of day one, the National Weather Service had issued 370 alerts. To put that in perspective, a busy severe weather day in the United States might produce 50 to 100 alerts. This is nearly 4 times that number, and it is only the opening act. Here is the detail that tells you this is not a normal severe weather outbreak. Wisconsin begins experiencing ice storm conditions and severe thunderstorms on the same day. South of the front, the air is warm and unstable, spawning tornadoes. North of the front, rain is falling through a shallow layer of sub-freezing air and turning to ice on contact with every surface it touches. 2 fundamentally different disasters are happening in the same state at the same time, generated by the same storm system. The surface low is tracking northeast, dragging the cold front behind it like a blade cutting the country in two. South and east of that line, chaos fueled by heat and moisture. North and west of that line, ice loading on power lines, freezing rain accumulating on roads, and temperatures crashing. The front is not just a weather boundary. It is a dividing line between 2 different seasons happening simultaneously. Think about what the first responders are dealing with right now. It is after midnight. The power is out for 150,000 people. Tornado-warned storms are still moving through parts of Ohio and Indiana. Trees are down across roads. There are reports of structural damage in multiple counties, and the 911 call centers are overwhelmed. Some departments are running mutual aid requests to neighboring counties, but those neighboring counties are dealing with their own damage. The safety net is stretched to the first thread. And here is the part that does not make the headlines: the psychological toll. When tornado warnings fire at 3 in the morning, families are scrambling for basements in the dark. Parents are carrying children downstairs they cannot see. People in mobile homes, the single most vulnerable housing type in severe weather, are being told to seek shelter elsewhere, but elsewhere is dark too and the roads are blocked. The stress of a nocturnal severe weather event compounds with every hour it continues, and this one continued all night. Day 1 ends with 370 alerts. The people who lost power tonight, some of them will not get it back before the next round hits, and tomorrow the alert count is going to climb to 469. Day 2, April 2nd. The system pushes east, and the alert count climbs, 469. That is the peak, the highest single-day total of the entire 5-day event. Nearly 500 simultaneous weather alerts from a single storm system, stretching from the Dakotas to the Atlantic seaboard. Missouri is dealing with flash flooding from the overnight deluge. Roads that were passable at midnight are underwater by dawn. Ohio's rivers are rising, fed by runoff from the same storms that knocked out power the night before. The severe threat has shifted into the Ohio Valley, where continued wind damage and an isolated tornado risk keep the region on edge. But the real story on day 2 is not the severe weather. The real story is the ice. 6 ice storm warnings are issued across the upper Midwest. This is the first round, not the compounding second event that will make headlines later in the week. This is the setup. And understanding what happens on day 2 is critical, because the ice that accumulates tonight is going to make everything that comes afterward dramatically worse. The mechanics of an ice storm are deceptively simple. When warm, moist air rides up and over a wedge of cold air trapped at the surface, rain falls from the warm layer aloft, passes through the cold layer near the ground, and arrives at the surface as a supercooled liquid. It is still in liquid form when it hits, but the moment it touches a power line, a tree branch, a road surface, anything below freezing, it freezes instantly. A thin, clear glaze of ice that adds weight to everything it touches. A quarter-inch of ice on a power line does not sound like much, but a quarter-inch of ice on a single span of wire, the distance between 2 utility poles, adds hundreds of pounds of weight. Multiply that across thousands of miles of power infrastructure, add wind gusts of 30 to 40 miles per hour, and the lines start coming down. Trees are even more vulnerable. Ice accumulates on every branch, every twig, every surface exposed to the freezing rain. A large oak tree can accumulate thousands of pounds of additional weight in a single ice event. The branches that fail first are the ones that were already stressed: old growth, storm damage, disease. And when they fail, they take power lines with them. The surface low tracks northeastward into the Great Lakes, dragging the cold front across the eastern Midwest. Behind that front, temperatures are in freefall. The same region that was dealing with severe thunderstorms 12 hours ago is now under winter weather advisories. Emergency management is being stretched in 2 directions simultaneously. Severe weather damage to the south requires debris clearance, power restoration, and structural assessment. Ice damage to the north requires entirely different equipment, entirely different expertise, and a fundamentally different response protocol. You cannot fight both disasters with the same resources, and the geographic overlap means some counties are dealing with both at once. One storm system, 2 fundamentally different disasters, playing out in real time across the same region, driven by the same cold front. On one side of that front, the air is warm enough to spawn tornadoes. On the other side, it is cold enough to glaze the world in ice, and both sides are advancing across the country together, like 2 armies marching in formation. The 469 alert day is the statistical peak of this event. But the damage is compounding, not peaking. Every hour of ice accumulation on day 2 is loading the infrastructure that will fail catastrophically on day 3 and day 4. The trees that are holding now will not hold when the second round of freezing rain arrives. The power lines that are sagging now will snap when the wind picks up. There is something almost disorienting about watching this unfold on the map in real time. You can pull up the NWS alert page and see the country painted in overlapping colours: red for tornado warnings, pink for ice storm warnings, blue for winter storm warnings, green for flood warnings, and they are all active simultaneously, all connected to the same system, all radiating outward from the same surface low like spokes on a wheel. It looks like the atmosphere is throwing a tantrum, and in a sense it is. The energy imbalance between the warm sector ahead of the front and the cold air behind it is enormous, and the atmosphere is trying to equalize that imbalance in the most violent way possible. Consider what is happening to the people in the transition zone, the narrow band where the warm sector gives way to the cold sector. In that band, you might get severe thunderstorms that transition to freezing rain within a few hours. The temperature drops from 55 degrees to 30 degrees in the time it takes to drive home from work. The rain on your windshield turns to ice on your power lines. The thunderstorm warning on your phone is replaced by an ice storm warning before you finish reading the first one. This is not how weather is supposed to work. Weather is supposed to give you time to adjust. This system is not giving anyone time. Day 2 set the stage. Day 3 is when the tornadoes really started. Day 3, April 3rd. Approximately 100 severe weather reports are filed across the Midwest in a single day. An estimated 7 to 8 tornadoes tear through Iowa, Illinois, and Wisconsin, with a possible tornado in Michigan. Only 2 are officially confirmed at this point, one in Texas and one in Iowa, because the National Weather Service has not had time to send survey teams to the rest. The damage is there. The confirmation is still catching up. The Storm Prediction Center maintains an enhanced risk for portions of Iowa and Missouri, and the hatched area appears on the Outlook map. That hatched area is significant. It indicates the possibility of significant, meaning strong to violent tornadoes. Not just garden variety spin-ups from a squall line. The kind that can level neighborhoods, the kind you see on the news. 2 distinct storm modes are operating simultaneously, and understanding the difference matters. Discrete supercells form in eastern Iowa and Michigan. These are the classic rotating thunderstorms that move as individual, isolated storms. They are the ones that produce the strongest tornadoes because they have room to breathe. The rotating updraft can organize, tighten, and produce a well-defined tornado that can stay on the ground for miles. The supercells in eastern Iowa and Michigan produce the most dangerous tornadoes of this entire outbreak. But most of the convection, the majority of the storm activity, organizes into QLCS structures. These are quasi-linear convective systems, the same type of organized storm line that caused so much damage on day 1. They are producing widespread damaging winds across a swath hundreds of miles long, and embedded within those lines are brief tornadoes that spin up with almost no warning. These QLCS tornadoes are sneaky. They form along the leading edge of the squall line, touch down for a few minutes, maybe a few hundred yards of damage path, and then dissipate before anyone can confirm them visually. The radar sees them, the velocity data shows the rotation, but by the time the warning goes out, the tornado may already be gone, or it may not. That uncertainty is what makes them so dangerous. The tornado threat peaks between 3 in the afternoon and 9 at night local time, but it does not end there. A nocturnal continuation pushes the threat past midnight, which means the most vulnerable hours, the hours when people are sleeping, when visibility is 0, when warning fatigue has set in, are also tornado hours. Nighttime tornadoes are statistically deadlier than daytime tornadoes. The data on this is unambiguous. People are less aware, less responsive, and less likely to reach shelter in time. In Lake Village, Indiana, an unconfirmed tornado rips through neighborhoods. Homes are flattened. Power lines are toppled. 2 people are confirmed dead. The National Weather Service will send a survey team to determine the tornado's rating, but for the families affected, the rating is irrelevant. The destruction is real regardless of whether it gets classified as an EF2 or an EF3. The alert count holds at 436, slightly below day 2's peak of 469, but the intensity of the damage is escalating because it is layering on top of what has already happened. Areas that lost power on day 1 still do not have it back. Areas that received ice on day 2 are now getting more ice, plus wind, plus the threat of tornadoes south of the front. While tornadoes are hitting Iowa and Illinois, ice is accumulating in Wisconsin. Emergency crews that were dispatched south to deal with tornado damage are being called back north to deal with ice damage. The resources cannot be in both places, and the storm does not care about logistics. This is also the same week that a G3 geomagnetic storm is active, the strongest since the Artemis II crew left Earth 3 days ago. The compound anomaly window we discussed in a previous video is still open. The sun is storming, the atmosphere is storming, and the infrastructure that connects modern civilization is caught in the middle. There is a term in emergency management called cascading failure. It describes a situation where the failure of one system triggers the failure of the next, which triggers the failure of the next, in a chain that accelerates as it progresses. A tornado knocks out a power substation. The substation outage disables the water treatment plant. The water plant failure triggers a boil water advisory. The boil water advisory requires bottled water distribution. The distribution centres are unreachable because the roads are flooded. Each failure feeds the next, and when you layer tornado damage, flood damage, and ice damage on top of each other within the same 72-hour window, the cascading failures multiply faster than the response system can address them. That is what is happening right now across the Midwest. It is not one disaster. It is a cascade of disasters, each one making the next one worse, each one depleting the resources that would have been available to address the next one if it had happened in isolation. All of that was yesterday. Today the ice storm is hitting areas that already got iced 48 hours ago. And tomorrow, the tornadoes are aiming at Ohio's biggest cities. Day 4 and Day 5, today and tomorrow. Day 4, today, April 4th, 2026. 296 alerts active, and the cold front is accelerating eastward, with the surface low lifting into Ontario. The system is beginning to exit the central United States, but it is not done. Not by a long shot. The SPC Day 1 outlook carries a slight risk for severe thunderstorms across southeastern lower Michigan, much of Ohio and portions of western Pennsylvania and New York. Sporadic damaging winds are the primary hazard, with an isolated tornado threat along the leading edge of the linear storm segments. The worst of the tornado risk from the Central Plains has shifted east, but it has not vanished. It has relocated, and it is now pointed at some of the most densely populated corridors in the eastern Midwest. For the people in these areas, Day 4 feels different than Days 1 through 3. The earlier days of the outbreak affected rural counties, small towns, agricultural communities, places where the population density is low and the damage, while devastating for those affected, does not generate the kind of mass casualty concern that a severe weather event in a major metropolitan area creates. Day 4 changes that calculus. Cleveland, with a metro population of 2 million, Columbus, with 2.1 million, Cincinnati, with 2.2 million, Pittsburgh at 2.3 million. These are not rural communities. A tornado in the Columbus metro area is a fundamentally different event than a tornado near Kelowna, Iowa, not because the wind is any different, but because the concentration of people, vehicles, buildings, and infrastructure in the damage path is orders of magnitude higher. Simultaneously, the ice storm is intensifying across the upper Midwest. This is the detail that separates a bad week from a catastrophic one. This is the second icing event in 48 hours for parts of Michigan's Upper Peninsula and northern Wisconsin. The first round of freezing rain hit on Day 2. It loaded ice onto every power line, every tree, every exposed surface. Some branches cracked, some lines sagged. But many of them held. Barely. They were damaged, stressed, at their structural limits, but they held. Now the second round is arriving, and the trees that survived the first event are not starting from zero. They are starting from a position of compromised structural integrity. The fresh ice is not being added to clean branches. It is being added to branches that are already cracked, already bent, already carrying more weight than they were designed to hold. The physics are relentless. Each additional tenth of an inch of ice is not a linear increase in failure risk. It is exponential. The branch that held through a quarter inch of ice will not hold through 3/10, and when it fails, it is not just the branch that comes down. It is the power line beneath it, the transformer attached to the pole, and the service to every customer downstream. 26,000 customers are without power in Wisconsin and the Upper Peninsula as of Friday morning. The peak was 57,500 across both states combined. Crews are working in conditions that make restoration dangerous and slow. Ice on equipment, downed lines draped across roads, trees falling faster than they can be cleared. Portage County, Wisconsin alone has 14,773 outages. One county. Now look ahead to Day 5. Tomorrow, April 5th. The SPC Day 2 outlook carries a marginal risk from the eastern Carolinas to the mid-Atlantic coast as the cold front finally reaches the ocean. Isolated, damaging wind gusts will be the primary threat along the coast, and for most of the eastern seaboard, the event will feel like a strong spring storm and nothing more. But the real story on Day 5 is Ohio. The Columbus, Cincinnati, and Cleveland corridor carries the possibility of an isolated strong tornado if discrete supercells can develop in the warm sector ahead of the front. The tornado threat window is approximately 3 to 7 in the afternoon local time. That is a 4-hour window in which the atmospheric conditions, wind shear, instability, a trigger mechanism, could align to produce a tornado in one of the 3 largest cities in Ohio. Pennsylvania and New York cannot be ruled out. 35 to 40 knots of shear in the 500 to 1,000 meter layer, the layer of atmosphere closest to the ground, is more than enough to support tornado development if the storm mode cooperates. If even one discrete supercell forms ahead of the main line, it will have the ingredients to rotate. The ice and snow threat persists into Saturday across the upper Midwest. Warsaw, Wisconsin, and points northward face additional ice accumulation on top of existing damage. For some areas, this could be a third round of icing. The cumulative weight is approaching the threshold at which entire sections of forest canopy can collapse, taking power infrastructure with them for weeks, not days. 5 days. 5 different types of disasters, one storm system. And it is still producing hazards as it exits the country. There is a detail buried in the SPC outlooks that is worth pausing on. For the April 5th outlook covering Ohio, the forecasters note 35 to 40 knots of shear in the 500 to 1,000 metre layer. That is the low-level wind shear, the change in wind speed and direction in the lowest kilometre of the atmosphere, and it is one of the most important predictors of tornado potential. 35 to 40 knots of low-level shear is not marginal, it is robust. It is the kind of shear you see in significant tornado outbreaks, not in late-season cleanup rounds. If a discrete supercell manages to form ahead of the line in that environment, it will have every ingredient it needs to produce a strong, potentially violent tornado. The conditional probability is low, meaning it requires the right storm mode to verify. But the consequences if it does verify are severe, especially in a metropolitan corridor that includes Columbus, Cincinnati, and Cleveland. Over 5 million people live in those 3 metro areas combined, and tomorrow afternoon, between 3 and 7 in the evening, they will be in the potential impact zone. Now, if this were just a bad storm week, that would be one thing. Bad storm weeks happen. Multi-day severe weather outbreaks occur every spring. What does not happen, what has never happened in quite this way, is that the same country goes from the worst fire weather emergency in March history to ice storms in April. 5 days apart. That transition is what turns a severe weather event into a warning sign. And to understand why, we need to go back to what was happening 5 days before this disaster started. Part 6. The Ithaca Catastrophe and the Flooding Dimension. Before we rewind to the fire weather emergency, there is one more piece of this 5-day disaster that demands its own attention, because it illustrates the compound nature of this event in a way that statistics alone cannot capture. Ithaca, New York. A college town of roughly 30,000 people, home to Cornell University, tucked into the Finger Lakes region of upstate New York. On April 1st, the National Weather Service issued a flash flood emergency for Ithaca. A flash flood emergency is the highest level flooding alert the NWS issues. It is not a watch. It is not a warning. It is a step above a warning. It means life-threatening, catastrophic flooding is occurring right now. Not that it might occur, but that it is actively happening and people are in immediate danger. 4 feet of standing water in parts of Ithaca, roads impassable, vehicles submerged. The gorges that make the Finger Lakes region so scenic funneled the runoff into concentrated channels that overwhelmed every drainage system in their path. 4 feet of water is chest high on an average adult. It is enough to float a car. It is enough to sweep a person off their feet and carry them into a culvert where they cannot be recovered. Flash flood emergencies are rare. The NWS does not issue them lightly. They represent a threshold of severity that the agency reserves for the most extreme cases, and the fact that one was issued during this event, for a location in upstate New York, not the flash flood-prone desert Southwest or the Gulf Coast, underscores the sheer volume of moisture this system was carrying. Now expand the lens. As of April 4th, 5 flash flood warnings and 68 flood warnings are active across the Midwest and Ohio Valley. In Ohio, flash flood warnings cover Marion and Morrow counties, where 2 to 3 inches of rain fell with additional accumulation expected. Ashland, Holmes, Knox, Richland, and Wayne counties are under flood warnings. In Holmes County, streams are still rising from excess runoff. Roads are closed. In Oklahoma, flash flood warnings blanket McIntosh and Pittsburgh counties after 1.5 to 3 inches of rain. Flood warnings cover 6 additional counties, and the Neosho River near Commerce has reached minor flood stage. In Wisconsin, the Kickapoo River at Ontario is in minor flood, with Brush Creek contributing to flooding on the south side of town. Across Illinois and Indiana, flood warnings cover 7 counties. A flood watch extends across 17 counties and zones in northern Indiana and southwest Michigan through Saturday afternoon. This system has not just produced severe weather, it has dumped enough rain to raise rivers, close roads, and strand communities across more than a dozen states. There is a detail about the Ohio flooding that illustrates how compound events amplify each other. The soil across much of central Ohio was already near saturation from day 1 and day 2 rainfall. When the additional 2 to 3 inches fell on days 3 and 4, the ground had no remaining capacity to absorb it. Every drop ran off the surface directly into streams, ditches and storm drains already at or near capacity. In a normal rainfall event on dry ground, the soil acts as a sponge. It absorbs the first inch or so and releases it slowly into the water table over days and weeks. When the soil is pre-saturated from a previous event within the same week, that sponge effect disappears. The runoff is immediate, the stream response is rapid, and the flood peaks are higher and faster than they would have been from the same amount of rain on dry ground. The multi-day nature of this outbreak turned what would normally be a manageable 2 to 3 inch rainfall into a flash flooding emergency. The western New York multi-river flood event from earlier in the week adds another layer. 8 rivers, including Tonawanda Creek and Buffalo Creek, reached moderate flood stage. The hydrological footprint of this storm system stretches from the Neosho River in Oklahoma to Buffalo Creek in New York, a distance of over 1,000 miles. One system, one continuous rain-producing cold front, 1,000 miles of flooding, and then there is the baseball-sized hail that fell in Iowa. Not the flooding, not the tornadoes. Hail the size of baseballs, roughly 2 3/4 inches in diameter, weighing close to half a pound each, falling at terminal velocities that can exceed 100 miles per hour. A single hailstone that size will punch through a car windshield. It will crack roof tiles. It will kill livestock caught in the open. Multiply that by the thousands of hailstones falling per minute across the storm's hail swath, and the damage potential becomes enormous. This hail fell as part of the same system that was producing ice storms 300 miles to the north and flash flooding 200 miles to the east. The atmosphere was deploying every hazard type it had at the same time, across different parts of the same country, from the same storm. Now consider the paradox that makes all of this flooding so strange. The same region that experienced its lowest snowpack on record during winter 2025 through 2026. The same region where over 80% of SNO-TEL stations were in drought, where the US Drought Monitor showed 56% of the lower 48 in drought, is now experiencing significant flooding. The moisture deficit from the winter is far too massive for a single storm system to replenish. The drought has not been broken. The reservoirs are still low. Lake Powell is still forecast to fall below power pool elevation by December. But the contrast between the driest winter on record and an April flood event is staggering. The atmosphere has no middle gear left. Fire 5 days ago. Flooding today. No transition, no gradual shift. Just one extreme slamming into the next. There is a mental exercise that captures the insanity of this week better than any data point. Pick any county in the central United States, say a county in central Wisconsin. Now track what that county has experienced in the last 7 days. 7 days ago, it was under a heat advisory. The temperature was 20 degrees above normal. Wildfire risk was elevated. 5 days ago, the county was watching fire weather warnings on the evening news. 3 days ago, severe thunderstorm warnings were firing. Tornado warnings were scrolling across the bottom of the screen. The power went out around midnight. 2 days ago, the first round of ice started. Trees began cracking. The power that had just been restored went out again. Yesterday, the second round of ice hit. Today, winter storm warnings are posting 6 to 9 inches of snow on top of the ice. In 1 week, one county experienced conditions spanning 3 different seasons: summer heat, spring severe weather, and winter ice storms. The calendar did not move. The county did not move. The atmosphere moved around it, rotating through an entire year of weather in 7 days. And that fire weather emergency we keep mentioning? The one from 5 days ago? That is the part of this story that turns a bad week into something that might be historically unprecedented. Because when you understand what was happening on March 30th, and then you look at what is happening today, the scale of the atmospheric reversal becomes almost impossible to believe. Part 7. 5 days ago, the fire weather emergency. If you watched our video 5 days ago, the one about the heatwave blasting the United States, you saw what the atmosphere was doing on March 30th, 2026. You saw the data, you saw the warnings, and if you are watching this video now, You can see what the atmosphere is doing today. The contrast between those two videos is the story. It is the entire story. Everything else is context. On March 30th, 16 red flag warnings and 5 fire weather watches were active across 9 states: Wyoming, Nebraska, Colorado, South Dakota, Kansas, Oklahoma, Texas, New Mexico, and the broader High Plains. 16 red flag warnings is not a routine fire weather day. The SPC issued a rare critical fire weather risk with an isolated dry thunderstorm risk, meaning lightning without rain in an atmosphere so dry that a single spark could ignite thousands of acres. National Weather Service offices used language they described as not typically seen in March. Not the strongest fire weather they had seen in March, not typical. They were saying the language itself was unusual, that the words they were writing in the forecast discussion were words they did not normally have to use this early in the year. Relative humidity dropped to 8% in multiple zones. 8%. For reference, the Sahara Desert averages around 25% humidity. Death Valley typically runs around 10 to 15%. 8% is drier than most deserts on Earth, and it was happening across the American High Plains in the last week of March. Wind gusts of 55 to 70 miles per hour were forecast. The energy release component, a measure of how much energy a fire would release if ignited, exceeded the 90th percentile. The fuels on the ground were at August level dryness, not April, August. The vegetation, the grasses, the timber, all of it was as dry as it would normally be in the peak of summer fire season. And it was March. Wyoming's earliest red flag warning on record was February 15th, 2026, 6 weeks before the traditional fire season starts. That is not an incremental shift, that is a fundamental redrawing of the fire calendar. Black Hills Energy implemented precautionary power shutoffs affecting 370 customers. They were physically de-energizing power lines because the risk of a line sparking a wildfire was too high. They chose no electricity over the possibility of catastrophic fire. In March, the consequences were already materializing. Nebraska experienced the worst wildfire in its state history. Over 600,000 acres burned. Nationally, 13,658 wildfires were recorded in 2026 as of late March, nearly double the 10-year average. Over 1.4 million acres burned, triple the 10-year average. And the traditional fire season had not even started yet. That was 5 days ago. The same jet stream that cooked the western United States into August-level fire conditions has now flipped. The ridge that built the heat collapsed. The trough replaced it. And instead of fire weather, the country is getting ice. Instead of 8% humidity, it is getting 4 feet of standing water in Ithaca. Instead of precautionary power shutoffs to prevent wildfire ignition, it is getting involuntary power outages from ice-loaded lines collapsing under their own weight. The hazard type has inverted completely, but the infrastructure under stress is the same. Think about the emergency managers in Wyoming and Nebraska right now. 5 days ago, they were coordinating wildfire suppression. They were staging tanker aircraft and positioning hotshot crews. They were briefing county officials on evacuation routes for fire. Today, their colleagues in Wisconsin and Michigan are coordinating ice storm response. Completely different equipment, completely different protocols, completely different training. The National Guard units that were on standby for fire suppression a week ago are now being activated for snow removal and emergency power generation. The whiplash is not just atmospheric, it is institutional. The entire emergency management apparatus of the United States is being asked to pivot between disaster types faster than the logistics allow. And this is just the fire weather side of the story. The heatwave that caused it, the one that shattered every March temperature record in the book, is what makes this whiplash historically unique. Because the heatwave was not a normal warm spell, it was something climate scientists said should not have been possible. Part 8. The heatwave that broke March. The fire weather emergency did not appear out of nowhere. It was the tail end of the most extreme heatwave in the history of the month of March, a heatwave so far outside historical parameters that climate scientists immediately began running attribution studies to determine whether it could have occurred without human-caused warming. The answer came back fast and it was unequivocal. 14 states shattered their all-time March temperature records, not daily records, not monthly averages. all-time records for the entire month. Records that had stood for decades were broken by margins that shocked the meteorologists recording them. Over 1,500 individual temperature records were broken across the country in a single month. That is not a warm spell. That is a systemic failure of historical norms. The national March record was demolished. 112 degrees Fahrenheit, recorded at Buttercup and Squaw Lake in California. The previous record of 108 degrees was obliterated by 4 degrees, a margin that in climate terms is not incremental but violent. Phoenix hit 105 degrees in March. Denver approached its warmest March on record. Temperatures across the western and central United States ran 10 to 20 degrees above normal, not for a day or a weekend, but for weeks. The heat did not just break records, it reshaped the physical environment. It baked moisture out of the soil. It accelerated snowmelt from a snowpack that was already at its lowest recorded level. Colorado and Utah measured their lowest snowpack on record. Over 80% of SNOT-EL stations, the automated sensors that measure snowpack depth across the western mountains, were in drought conditions. MODIS satellite imagery showed the lowest western snow cover since 2001 at 141,416 square miles on January 4th. The US Drought Monitor showed 56.21% of the lower 48 in drought as of March 24th. The Bureau of Reclamation, the federal agency responsible for Western water infrastructure, forecast Lake Powell falling below Power Pool elevation by December 2026. Power Pool is the minimum water level at which the dam can generate electricity. Below that line, the hydroelectric turbines stop spinning. Hoover Dam and Glen Canyon Dam, two of the most important power generating facilities in the American West, are approaching thresholds that were supposed to be theoretical. The World Weather Attribution Group, a rapid analysis consortium of climate scientists from universities and research institutions worldwide, published a study on the March heatwave within days of its occurrence. Their conclusion: the temperatures experienced in the western United States in March 2026 would have been, and this is a direct quote, virtually impossible without human-induced climate change. They found that climate change made the event 800 times more likely and added between 4.7 and 7.2 degrees Fahrenheit to the peak temperatures. Without the background warming caused by greenhouse gas emissions, this heatwave simply could not have happened. That matters here, in a video about ice storms and tornadoes, because the heatwave and the compound disaster are not separate stories. The heat built the potential. The ridge loaded the atmosphere with energy over the western United States for weeks. When that ridge collapsed, when the pattern flipped and the trough drove southward, all of that stored energy had to go somewhere. It went into the moisture. It went into the temperature gradients. It went into the jet stream dynamics that are now producing tornadoes and ice storms and blizzards and flooding simultaneously. The March heatwave is the first half of the sentence. The April compound disaster is the second half. You cannot understand one without the other. There is a number from the World Weather Attribution Study that deserves emphasis. They found that climate change added 4.7 to 7.2 degrees Fahrenheit to the peak temperatures during the March heatwave. Think about what that means in practical terms. Without the additional warming from greenhouse gas emissions, the hottest March day in US history would have been around 105 to 107 degrees. Still extremely hot, still record-breaking in some places, but not the 112-degree civilization-straining event that actually occurred. Those additional degrees are the difference between a severe heatwave and a heatwave that rewrites the record books by double digits. Those additional degrees are the difference between a dry landscape and an August dry landscape in March. And those additional degrees of heat are now expressing themselves as additional degrees of atmospheric instability. Additional energy driving the compound disaster we are watching today. The heat did not just break records and disappear. The heat reshaped the atmosphere. It redrew the energy budget. And the compound disaster is the receipt. Part 9. The Whiplash. From fire to ice in 5 days. This is the core of the entire story. This is the moment that separates 2026 from every other spring on record. So let me state it as plainly as I can. The United States went from its hottest March on record, fire weather emergencies across 9 states, 112 degrees Fahrenheit, 8% relative humidity, precautionary power shutoffs to prevent wildfire ignition, to ice storms, blizzards, flash flooding, and 296 simultaneous weather alerts in the first week of April. The time between those two realities was 5 days. 5 days. Quantify the temperature swing and it becomes even more disorienting. Locations across the central United States experienced all-time March heat records, temperatures 20 to 30 degrees above normal, followed within days by freezing rain and snow in early April. The temperature departure in some areas spans 30 to 50 degrees Fahrenheit. Not across the span of a season, across the span of a week. On Monday, you are running your air conditioning and watching fire weather warnings scroll across your phone. By Friday, ice is accumulating on your power lines and the National Weather Service is warning you not to drive. That is not a seasonal transition. A seasonal transition is gradual. It is week over week, with occasional setbacks, a slow warming trend punctuated by late-season cold snaps. What happened between late March and early April 2026 is not that. What happened is a violent atmospheric regime change, a sudden and complete reorganization of the jet stream pattern over North America that replaced one extreme with its polar opposite in a matter of days. Here is what happened mechanically. The ridge that produced the March heatwave, the high-pressure dome that parked over the western United States and baked the continent for weeks, created a downstream trough to the east. That is normal atmospheric dynamics. A ridge forces the jet stream north, and downstream, the jet stream compensates by diving south. The problem is that this ridge was not normal. It was amplified far beyond historical norms, and the downstream trough it created was equally amplified. When the next shortwave disturbance, a ripple in the jet stream, undercut the ridge from the west, it triggered a pattern collapse. The ridge broke down. The trough deepened and expanded. Cold air from the Arctic, which had been held north by the ridge, poured south into the vacuum. And all of the energy that had been building, the heat, the moisture gradients, the temperature contrasts, was released in the form of the 5-day compound disaster we are now living through. The same jet stream amplification that produced the record heat also produced the trough that is now driving the tornadoes, the ice storms, the blizzards, and the flooding. These are not unrelated events that happen to occur in the same week. They are cause and effect. They are two expressions of the same atmospheric pattern. The heat was the loading phase. The compound disaster is the release phase. The boundary between them was the cold front that started this outbreak on April 1st. The infrastructure consequences are severe and compounding. The power grid that was stressed by fire weather less than a week ago is now being stressed by ice loading. The emergency services that were deployed for wildfire prevention are now being redeployed for flood and ice response. The fuel moisture that was at August-level dryness is still at those levels in the western states. The ice and rain have not reached the areas that need it most. The drought persists. The fire risk will return the moment the pattern shifts again. And when it does, the vegetation that survived the March fire weather will be even more stressed than it was before, because the April storms have added a freeze-thaw cycle to the drought stress, damaging root systems, killing early season growth and leaving the fuel load in worse condition than it was a month ago. Here is something that rarely gets discussed in the immediate aftermath of a compound event like this: the psychological toll on the populations caught in the whiplash zone. Emergency management research has shown that people who experience rapid succession disasters in different categories, a heat emergency followed by a flood, or a wildfire followed by a winter storm, exhibit higher rates of anxiety, decision fatigue, and evacuation non-compliance than people who experience a single large disaster. The reason is intuitive. Each new hazard type requires a different mental model, different preparation, different action. When the hazard changes every 48 hours, people cannot maintain the sustained vigilance that any single disaster demands. They check out. They stop responding to warnings. They assume the next alert is just noise, and that is when casualties climb. And here is what keeps the forecasters up at night. The speed of this reversal has no clean historical precedent. There are analogues for extreme March heat waves. There are analogues for April ice storms. There are analogues for 5-day severe weather outbreaks. But there is no analogue in the modern weather record for all of them happening in sequence, within the same week, in the same country, driven by the same jet stream pattern. Forecasters are reaching for comparisons that do not exist. So the question that this video has been building toward, the question that the data makes unavoidable, is whether the boundary between seasons has actually collapsed. Not metaphorically, not as a figure of speech, but as a physical reality. Has the atmospheric machinery that once separated winter from spring from summer become unstable enough that these kinds of reversals are now possible? And if so, what does that mean for everything? The power grid, agriculture, emergency management, water supply, the very concept of seasonal planning, that depends on a predictable transition between seasons. The answer involves 3 letters, a warming ocean, and something called a sudden stratospheric warming event. And the answer is not reassuring. There is a way to visualize what happened that might help. Imagine the jet stream as a river, a fast-flowing current of air 5 to 7 miles above the surface, circling the northern hemisphere from west to east. In a stable pattern, that river flows in smooth, gentle curves. The warm air stays south of it, the cold air stays north of it. Seasons change gradually because the river shifts north in summer and south in winter, slowly, predictably. Now imagine someone grabs that river and yanks it, hard, first north, creating a ridge that allows subtropical air to flood into places it does not belong, 112 degrees in March. Then the river snaps back south, even harder, creating a trough that drags Arctic air down into places that were baking a week ago. Ice storms in April. The whiplash is the river overcorrecting, oscillating between extremes like a pendulum that has been pushed too hard. Each swing is bigger than the last. Each correction overshoots the other direction. And the regions caught in the middle, the central United States, the Midwest, the Great Lakes, experience the full amplitude of every swing. That is not a metaphor. That is, almost literally, what the jet stream did between late March and early April 2026. And the question of why it did that, why the swings are getting bigger, why the corrections are getting more violent, requires looking at 3 things that are all going wrong at the same time. Part 10. The atmospheric mechanics. Why one storm can do 5 things at once. The first piece of the puzzle is ENSO, the El Niño Southern Oscillation. If you have watched this channel before, you know ENSO is the single largest driver of seasonal weather patterns on the planet. It is an oscillation between warm and cold phases in the tropical Pacific Ocean, and depending on which phase is active, it anchors the jet stream in predictable configurations. La Niña pushes the jet north over the western United States and south over the eastern United States. El Niño does roughly the opposite. When you know which phase is active, you can make reasonable predictions about what winter and spring will look like. Right now, ENSO is in transition, and transition periods are when the atmosphere gets weird. The Oceanic Niño Index, the standard measure of ENSO phase, shows La Niña weakening rapidly. The ONI was negative 0.55 in October through December of 2025. That is solidly La Niña. By November through January it was negative 0.54, essentially unchanged. Then it started moving. December through February, negative 0.37. January through March, negative 0.16. La Niña is collapsing. The cold pool in the central Pacific that defined the winter pattern is dissipating. The tropical forcing that anchored the winter jet stream is dissolving, and the atmosphere is reorganizing. By June through August of 2026, El Niño is expected to emerge, with a 62% probability. The atmosphere is caught between 2 states right now, no longer La Niña, not yet El Niño, and that in-between period is historically associated with the most volatile and unpredictable jet stream configurations. The steering currents that push storms along predictable tracks lose their anchor. The jet stream starts to wobble, buckle, and amplify in ways that seasonal forecasts struggle to capture. The second piece is the polar vortex. During winter 2025 through 2026, 3 sudden stratospheric warming events occurred, the most in a single winter in recent memory. A sudden stratospheric warming event is exactly what it sounds like. The stratosphere, 10 to 30 miles above the surface, warms by as much as 50 degrees Fahrenheit in a matter of days. This disrupts the polar vortex, the ring of cold, fast-moving air that normally contains Arctic air masses at high latitudes. When the polar vortex is disrupted, the jet stream loses its discipline. Instead of flowing in relatively smooth west-to-east waves, it buckles into exaggerated loops, deeper troughs that pull Arctic air further south than it normally reaches, and higher ridges that push subtropical air further north. The result is simultaneous extreme heat and extreme cold at different longitudes. Sound familiar? That is exactly the pattern that produced the March heatwave in the west. and is now producing the April ice storms in the upper Midwest. 3 SSW events in one winter means the polar vortex was disrupted not once, not twice, but 3 times. Each disruption weakened it further. By late March, the residual effects of those disruptions were still influencing the jet stream configuration, contributing to the amplified pattern that allowed both the heat wave and the compound disaster. The third piece is the ocean. On March 22, 2026, the global average sea surface temperature reached 21.126 degrees Celsius, the highest value ever recorded. The oceans are warmer than they have ever been in the measurement era. Warmer oceans mean more moisture evaporating into the atmosphere, which means more energy available for every weather system that forms. This is why one storm system can produce tornadoes and ice storms and blizzards and flooding all at the same time. The moisture supply is unprecedented. The Storm Prediction Center specifically noted seasonably high, precipitable water values in its outlooks for this event, meaning the atmosphere was holding more moisture than is typical for early April. That moisture falls as rain south of the front, as freezing rain in the transition zone where warm air rides over cold air at the surface, and as snow on the cold side of the front. All forms of precipitation, all at once, all from the same moisture source. There is a concept in atmospheric science called the Clausius-Clapeyron relationship. It describes how the atmosphere's capacity to hold moisture increases by roughly 7% for every 1 degree Celsius of warming. The oceans have warmed by over 1 degree Celsius in the last century, which means the atmosphere can now hold roughly 7 to 10% more moisture than it could 100 years ago. 7 to 10% may sound modest. It is not. Applied across an entire continental weather system, a 1,000-mile cold front drawing moisture from the Gulf of Mexico for 5 consecutive days, that additional 7 to 10% translates into billions of additional gallons of water being cycled through the system. More rain, more snow, more freezing rain, more hail. Every form of precipitation gets a boost, and the cumulative effect over a multi-day event is transformative. Put the 3 pieces together and you have the atmospheric recipe for the collapse of seasonal boundaries. ENSO is in transition, leaving the jet stream unanchored. The polar vortex has been disrupted 3 times, leaving the jet stream amplified, and the oceans are at record warmth, supercharging every system that forms with more moisture and energy than any historical analogue would predict. The machinery that normally creates a stable, gradual transition between seasons, the jet stream, the polar vortex, the ocean-atmosphere coupling, is all running outside its historical parameters simultaneously. The boundary between seasons is not collapsing because of one storm. It is collapsing because every major atmospheric driver is destabilized at the same time, and that atmospheric chaos does not just affect the weather. It affects everything that depends on the weather, starting with the power grid and the millions of people who are right now sitting in the dark waiting for the ice to stop falling. Part 11. The Ice Storm Deep Dive. 8 distinct ice storm warnings are in effect across the upper Midwest as of April 4th, and the geographic detail matters here because each warning area tells a different story about who is being affected and how badly. Start with Michigan's Upper Peninsula, central and eastern Chippewa County, western and eastern Mackinac County, up to 1/3 of an inch of ice, with east winds gusting 30 to 35 miles per hour. Gogebic, Iron, and Dickinson counties are getting the worst of it. 3/10 to 4/10 of an inch of ice. That 4/10 of an inch figure is the heaviest accumulation in the entire event. It does not sound like much until you understand the physics. 4/10 of an inch of ice on a single large tree can add over 1,000 pounds of weight. On a power line span, it can add 500 pounds or more. With 35-mile-per-hour wind gusts applying lateral force to that ice-loaded infrastructure, the failure threshold drops dramatically. Alger, Luce, Delta, and northern and southern Schoolcraft counties are forecast for 1/10 to 3/10 of an inch of ice, with winds gusting 35 miles per hour. Braga, Marquette, Ontonagon, and southern Houghton are in the same range, with the heaviest accumulation expected in areas of high terrain where freezing rain rates increase due to orographic lift. The air is forced upward by terrain, squeezing out more moisture as it rises. Quinair and northern Houghton are under a winter storm warning rather than an ice storm warning, because their primary hazard is different. Up to 2 inches of additional snow and sleet on top of 2/10 of an inch of ice, with wind gusts reaching 40 miles per hour. The combination of ice, snow and wind in the Keweenaw Peninsula is enough to shut down travel entirely. Cross into Wisconsin and the ice storm warnings continue. Marathon, Menominee, northern Oconto, Shawano and southern Marinette counties, 1/10 to a quarter inch of ice. Vilas, Oneida, Forest, Florence, northern Marinette, Lincoln and Langlade counties, 2/10 to 3/10 of an inch. Bayfield, Ashland, Iron, Burnett, Washburn, Sawyer and Price counties, up to a quarter inch of ice with 2 inches of snow and sleet. The geographic scope of these warnings covers most of northern Wisconsin, from the Lake Superior shoreline to the central part of the state. There is a detail within these warnings that often gets overlooked in national coverage: the tribal lands within the affected areas, Bad River Reservation, the St. Croix Band, Lac du Flambeau Band, Red Cliff Band, Lac Courtoreille Band. These communities are within the ice storm warning zones, and they often have the least resilient power infrastructure and the longest restoration timelines. When a major utility company loses a transmission line, restoration crews can be on site within hours. When a tribal utility serving a remote reservation loses its distribution network to ice loading, the restoration timeline can be measured in days or weeks. The critical operational detail that makes this ice storm different from a typical early April icing event is that it is the second icing event within 48 hours. The first round hit parts of these same counties on day 2 of the outbreak. It deposited a base layer of ice on every exposed surface: power lines, tree branches, communication towers, road signs. Some of that infrastructure failed during the first round, and crews have been working to restore it, but much of it survived, damaged and stressed but functional. Now the second round is adding fresh ice on top of that base layer. The cumulative effect is not additive, it is exponential. A tree that held through a quarter inch of ice on its branches is carrying that weight, plus whatever new ice accumulates. The failure curve is not linear, it is a cliff. At some threshold, different for every tree, every branch, every power line span, the cumulative load exceeds the structural capacity and everything comes down at once. And when one tree fails onto a power line, the cascading effect can take out an entire distribution circuit. 26,401 customers are without power in Wisconsin and the Upper Peninsula as of Friday morning. The peak was 57,500. In Portage County, Wisconsin alone, 14,773 customers lost power. Crews are reporting that ice on their own equipment is slowing restoration efforts. Bucket trucks cannot operate safely when the ground is covered in ice and the trees above are shedding ice-loaded branches unpredictably. 18 winter storm warnings extend from Minnesota through North Dakota. The Minnesota Arrowhead, the northeastern corner of the state, is expecting 6 to 9 inches of snow with wind gusts of 35 to 40 miles per hour. Visibility will drop below a quarter mile at times, creating ground blizzard conditions. North Dakota's James River Valley is under warning for 2 to 6 inches with 35 mile per hour gusts. Travel will be very difficult to impossible in the warning areas. The snow is falling on Voyageurs National Park and the Boundary Waters Canoe area. These are some of the most remote locations in the lower 48, and the roads that access them will be impassable for days. Anyone currently in the backcountry is dealing with conditions they did not plan for in early April. Emergency crews that have been responding to severe weather damage in the southern portions of these states, tornado damage, wind damage, flooding, are now being redeployed northward to deal with ice-related emergencies. The same state emergency management agencies are running 2 simultaneous disaster responses for 2 fundamentally different hazard types: severe weather to the south, ice storms to the north, same week, same storm, same resource pool that cannot be in 2 places at once. There is an irony that is hard to ignore. The same region that had its lowest snowpack on record this winter, the same region where 80% of monitoring stations were in drought, is now receiving ice and snow in April. The drought is not broken. The moisture deficit is far too enormous for one storm to replenish, but the contrast between the driest winter on record and an April ice storm that is knocking out power to tens of thousands of people is jarring enough to make you wonder what atmosphere you're living under. And if you think the whiplash between fire and ice is extreme, wait until you hear what the Arctic is doing. because the signal driving this entire pattern starts thousands of miles north of the ice storm warnings, in a part of the world where the ice is not accumulating. It is disappearing. Part 12. The Arctic Signal. NASA's Earth Observatory reported on April 3, 2026, that the Arctic sea ice extent in March tied the lowest maximum ever observed in the satellite record. The Arctic reached its annual peak ice coverage on March 15th at 5.52 million square miles, 14.29 million square kilometres. For the second consecutive year, the winter maximum has matched the lowest point since satellite monitoring began in 1979. That peak is 500,000 square miles below the 1981 to 2010 average. 500,000 square miles of ocean that used to be covered by ice in March is now open water. And ICESAT-2 satellite data, NASA's laser altimetry mission that measures ice thickness from orbit, shows that the ice that does exist is thinner than expected. The Barents Sea in particular had patches of open water that contributed disproportionately to the low extent. Barents Sea ice in mid-March 2026 was, according to NASA, very thin. Why does Arctic sea ice matter in a video about tornadoes and ice storms in the Midwest? Because the Arctic is the engine that drives the jet stream. The jet stream exists because of the temperature difference between the cold polar regions and the warmer mid-latitudes. That temperature gradient is the fuel. The stronger the gradient, the faster and more linear the jet stream flows. The weaker the gradient, the more the jet stream wobbles, buckles, and forms exaggerated waves. Arctic amplification, the phenomenon in which the Arctic warms 2 to 4 times faster than the global average, is reducing that gradient year over year. As the Arctic warms and ice extent decreases, the temperature contrast between the pole and the mid-latitudes shrinks. A weaker gradient means a weaker, wavier jet stream. A wavier jet stream means deeper troughs pulling cold air further south and higher ridges pushing warm air further north. Both extremes get more extreme, both become more frequent, and the transitions between them become more sudden and more violent. This is the engine behind the whiplash. The same Arctic amplification signal that allows the jet stream to buckle far enough to produce 112 degrees in March also allows it to buckle far enough to produce ice storms in April. The record heat and the ice storms are not contradictions. They are both products of the same weakening gradient, the same amplified jet stream, the same planetary scale signal that starts with open water in the Barents Sea and ends with power outages in Wisconsin. When you see the headline that Arctic sea ice just tied its lowest maximum on record, do not think of it as a polar story. Do not file it under environment and move on. Think of it as a weather story, your weather story. Because the signal that is melting ice in the Barents Sea is the same signal that just collapsed the boundary between seasons across America. The connection is not theoretical. It is playing out in real time, right now, in the form of 296 weather alerts and a country that went from fire to ice in 5 days. There is a phrase that climate scientists use that captures this dynamic. Arctic amplification does not mean the Arctic gets warm and everywhere else stays the same. It means the Arctic gets warm, the temperature gradient weakens, the jet stream destabilizes, and the weather in the mid-latitudes, where most humans live, where most agriculture happens, where most infrastructure exists, becomes more extreme in both directions simultaneously. Hotter heat waves and colder cold snaps, longer droughts and more intense flooding, worse fire seasons and more damaging ice storms, not one or the other, both, at the same time, in the same year, sometimes in the same week. That is what this week looks like. That is what this video has been documenting for the last hour and a half, and that leads directly to a question that a lot of people are asking right now. Not about the science, but about the alternative explanations. Now, not everyone sees it that way. There are alternative theories about what is driving this pattern, and some of them are gaining traction fast. Part 13. The conspiracies and alternative angles. Claims are circulating on social media right now. They have been circulating since the March heatwave, and they have intensified since the ice storm started, that the severity and timing of this weather pattern are evidence of weather modification or geoengineering programs. The argument goes like this. The transition from 112 degrees and fire weather emergencies to ice storms and blizzards in 5 days is too fast, too extreme, and too convenient to be natural. Therefore, someone is doing this deliberately. The weather is being manipulated. Let me address that directly. No weather modification technology exists, none that has been disclosed, none that is theoretically feasible with current engineering, that could produce a multi-day severe weather outbreak covering 30-plus states, generating tornadoes, ice storms, blizzards, and flash flooding simultaneously over 5 days. The energy involved in this storm system is on the order of multiple nuclear weapons detonated per hour. The scale is planetary. The idea that a human technology could manufacture this, could steer a jet stream, deepen a surface low, generate 3,000 joules per kilogram of CAPE across a 1,000-mile warm sector, does not withstand even basic scrutiny of the physics involved. The pattern, while extreme, is consistent with known atmospheric dynamics during ENSO transitions and periods of jet stream amplification. We just walked through the mechanics: La Niña collapsing, polar vortex weakened by 3 SSW events, record ocean temperatures supercharging moisture transport. Every ingredient in this disaster has a documented, measurable, physically understood cause. The atmosphere does not need a conspiracy to produce this, it just needs the conditions we have given it. A second thread of speculation connects this weather to the ongoing geomagnetic storm. A G3 geomagnetic storm, the strongest since the Artemis II crew launched, has been active this same week. The temporal overlap is real, and some are claiming a direct causal link between solar activity and the severe weather outbreak. The science here is nuanced. There are theoretical mechanisms by which solar activity can influence atmospheric circulation, primarily through effects on the stratospheric polar vortex. Energetic particles from solar storms can alter ozone chemistry in the upper stratosphere, which can in turn affect temperature gradients, which can propagate downward to influence the tropospheric jet stream. The Kyoto capacitive coupling model, which we have discussed in previous Project Nightwatch videos, suggests that the relationship between solar activity and Earth systems may be more complex than conventional models account for. This is an active area of research, and the science is not settled. What is settled is that no mainstream peer-reviewed science supports a direct causal link between a single geomagnetic storm and a specific severe weather outbreak. The temporal overlap, as a G3 storm during the same week as a compound weather disaster, is coincidental in the scientific consensus view. Correlation is not causation, and the atmospheric drivers of this event are fully explicable without invoking solar forcing. The ENSO transition, the SSW events, and the record ocean temperatures are more than sufficient to produce exactly what we are seeing. A third thread of speculation uses the April cold and snow to argue that climate change is a hoax. The logic, such as it is, runs like this. If the planet is warming, why is it snowing in April? Why are ice storms hitting the upper Midwest? Where is the global warming? The World Weather Attribution Study answers this directly. The March 2026 heatwave was virtually impossible without human-induced climate change, 800 times more likely. 4.7 to 7.2 degrees Fahrenheit added to peak temperatures by greenhouse gas emissions. The heatwave was not a natural fluctuation, it was a fingerprint of a changing climate. The April cold and ice do not contradict this. They are products of jet stream variability. The same amplified jet stream that produced the heat also produced the trough that is driving the cold air south. Both extremes coexist in an amplified pattern. Some research suggests that Arctic amplification actually makes these kinds of whiplash events more probable, not less, because a wavier jet stream can deliver both extreme heat and extreme cold to the same latitude in rapid succession. So the conspiracy is not that someone is controlling the weather. The reality is more unsettling than that. Nobody is controlling it. The atmosphere is oscillating between extremes faster than at any point in the modern record. The systems that are supposed to provide stability, the polar vortex, the jet stream, the ENSO cycle, are all running outside their historical parameters simultaneously. There is no villain in this story. There is only physics, and the physics says the guardrails are weakening. Here is a thought experiment that illustrates the point. Imagine you're explaining this week to someone from 1975. You tell them that in late March, 14 states set all-time temperature records for the month. The national March record hit 112 degrees. The high plains were drier than most deserts on Earth, and power lines were being shut off in Wyoming to prevent wildfire. Then you tell them that 5 days later, Ice storms were knocking out power to 57,000 people in Wisconsin, blizzards were burying Minnesota under 9 inches of snow, and tornadoes were hitting Iowa and Indiana. Same country, same week. The person from 1975 would not believe you. Not because these individual events are impossible. Heat waves happen, ice storms happen, tornadoes happen. They would not believe you because the sequence is impossible. The speed of the transition from one extreme to the other would violate everything they understood about how seasons work. The atmosphere they knew had guardrails. The atmosphere we are living in now is losing them, and the people who are living through that weakening, the ones sitting in the dark right now, the ones who lost their homes to tornadoes, the ones whose roads are underwater, they are the ones paying the price. Part 14. The human toll and infrastructure strain. Step back from the meteorology for a moment. Step back from the data and the jet stream diagrams and the ENSO indices. Look at what this 5-day disaster means for the people who are living through it right now. Over 150,000 customers have lost power at various points during this 5-day event. In Wisconsin and Michigan alone, the ice storms peaked at 57,500 outages. As of Friday morning, 26,401 customers remain without electricity. In Portage County, Wisconsin, one county, 14,773 households and businesses are dark. That is not a statistic. That is 14,000 families without refrigeration, without heating, without the ability to charge phones, without the medical equipment that some of them depend on to survive. 2 people are confirmed dead in Lake Village, Indiana. An unconfirmed tornado ripped through neighborhoods, flattening homes and toppling power lines. Families are sifting through debris. The National Weather Service will send a survey team to rate the tornado and add it to the official record. But for the people who were in those houses when the walls came down, the EF rating is meaningless. The loss is the same whether the wind was 110 miles per hour or 150. Roads are closed across multiple states. In Holmes County, Ohio, streams are still rising from excess runoff and roads remain impassable. In Ithaca, New York, 4 feet of standing water turned streets into rivers. In Michigan's Upper Peninsula, downed trees and power lines have blocked routes that serve as the only access to remote communities. The infrastructure of daily life, the ability to drive to work, to get to a hospital, to buy groceries, has been disrupted for millions of people across more than 20 states. Emergency services are stretched beyond their design capacity. This is a point that gets lost in the headline numbers, but matters enormously on the ground. Emergency management is built around the assumption that a region will face one type of disaster at a time. A tornado response requires search and rescue teams, debris clearance equipment, structural engineers, and sheltering capacity. An ice storm response requires line crews, tree removal equipment, generator deployment, and warming centres. A flood response requires swift water rescue teams, pumps, and sandbagging operations. This event is demanding all 3 simultaneously, in the same states, in the same week. The personnel trained for severe weather response are being asked to pivot to ice storm recovery. The equipment positioned for tornado debris clearance in the southern part of a state is being requested in the northern part for tree removal from ice damage. You cannot fight 3 different disasters with the same resources at the same time, and the geographic overlap means some emergency management agencies are trying to do exactly that. The whiplash between fire and ice compounds the strain in ways that are hard to quantify. 5 days ago, Wyoming was turning off power lines to prevent wildfires. Today, Wisconsin's power lines are collapsing under the weight of ice. Different states, different hazards, but the same fundamental vulnerability. The power grid was not designed for this level of atmospheric volatility. It was designed for one season at a time, with a transition period between them. When that transition period vanishes, the grid is hit by stresses it was never engineered to absorb in rapid succession. The tribal communities within the ice storm warning zones face compounded challenges. Bad River Reservation, the St. Croix Band, Lac du Flambeau Band, Red Cliff Band, Lac Courtereille Band. These communities are served by smaller utilities with fewer crews and longer restoration timelines. When a major utility serving a city of 50,000 loses a feeder line, crews can typically restore power within hours. When a tribal utility serving a reservation of a few thousand people loses its primary distribution network to ice loading across dozens of miles of remote territory, The restoration can take a week or more, and during that week, the temperatures outside are below freezing. Schools are closed, flights are disrupted. Agricultural damage is accruing on two fronts. The fire weather dried crops and depleted soil moisture across the plains, and the ice is now damaging fruit trees across the upper Midwest that had already begun budding due to the unseasonably warm March. When trees bud early because of heat and then get hit by an ice storm, the buds die. That represents an entire season's harvest for some orchards. Cherry growers in Michigan, apple orchards in Wisconsin, peach farms across the upper Midwest. All of them saw their trees respond to the March warmth by budding weeks early. The trees did what they are biologically programmed to do. They sensed warmth and began the process of reproduction. Now ice is killing those buds, and there is no second chance. The growing season for those orchards may be over before it began. The insurance implications are staggering. Homeowners who just filed claims for wind damage are now filing claims for ice damage on the same property in the same week. Auto insurance claims from hail damage are overlapping with claims from accidents on ice-covered roads. Agricultural crop insurance adjusters are being asked to assess damage from both drought stress and frost kill on the same fields. The actuarial models that insurance companies use to price risk are built on historical weather patterns that assumed heat waves and ice storms do not happen in the same week. When they do, the models break. This is what happens when seasons collapse. Infrastructure is designed for one type of weather at a time. Emergency management is designed for one disaster at a time. Agriculture is planned around predictable seasonal transitions. When fire, ice, tornadoes, and flooding all happen in the same week, every system designed to protect people from the weather gets overwhelmed. Not because any single event exceeded its capacity, but because the events came too fast, too different, and too close together for any system to adapt. And if you are hoping this is the worst of it, that the pattern is about to settle down and give everyone a chance to recover, I need to show you what the extended outlook says, because it is not good news. Part 15. This is not over. The Weather Prediction Center's extended forecast shows a split flow pattern developing over the United States next week. For those who are not familiar with the term, a split flow means the jet stream divides into two distinct branches. A northern branch pushing cold air and storm systems across the northern tier of the country, and a southern branch pushing warm, moist air and storm systems across the southern tier. In between, the atmosphere is disorganized and chaotic, which sounds like a break but actually means the opposite. Split flow patterns are precursors to more compound events, because they allow warm and cold air masses to interact along a broad and unstable boundary, rather than a single defined front. That split flow is expected to drive another round of precipitation into the central United States. Not a passing shower, not a one-day event, a sustained multi-day period of rainfall that the forecast models are flagging as potentially significant. The GFS and the European model, the two primary global weather models that forecasters rely on for extended range guidance, are in broad agreement on the setup, which increases confidence that this is not a model artifact. When the two major models converge on a pattern a week out, forecasters pay attention. The Climate Prediction Center, CPC, has issued moderate and high-risk potential for excessive rainfall extending into week 2. Moderate and high risk on the CPC excessive rainfall outlook is not routine language. It means there is meaningful probability that the rainfall totals over the next 7 to 14 days will be heavy enough to produce widespread flooding. Consider the timing. The rivers that are flooding right now, the ones in Ohio, Oklahoma, Wisconsin, Indiana, western New York, have not crested yet in some cases. Flood warnings are still active across 68 locations. The soil is saturated from 4 days of heavy rain, and the forecast says more rain is coming before the current round has even finished draining. You do not need to be a hydrologist to understand what happens when you add heavy rain to already saturated ground above already swollen rivers. The water has nowhere to go except up. The ice and snow threat is not done either. The system persists into Saturday across the upper Midwest. Warsaw, Wisconsin, and areas northward face additional ice accumulation on top of existing damage. For some communities, this will be the third round of icing. There is a threshold of cumulative ice loading beyond which the damage stops being incremental and starts being structural. Entire sections of forest canopy collapsing, utility poles snapping at the base, distribution networks failing in ways that require not just repair, but reconstruction. 3 rounds of icing in 1 week pushes many areas past that threshold. Zoom out further, and the fire season looms over everything. The 1.4 million acres that have already burned nationally in 2026, triple the 10-year average, were burned before the traditional fire season even started. Nebraska's 600,000-acre wildfire, the worst in state history, happened in March. The western drought has not been touched by this storm system. The moisture from the April flooding is falling on the Midwest and the East, not on the dry fuels across Colorado, Wyoming, Nebraska, and the High Plains. Those fuels are still at August-level dryness. The fire risk will return the moment the jet stream shifts back to a ridging pattern, and there is nothing in the extended models that says it will not. The ENSO transition is accelerating, and that has implications for the rest of spring and summer. La Niña is collapsing. El Niño is loading, with a 62% probability of emergence by June through August. Historically, the transition from La Niña to El Niño is associated with increased severe weather activity across the central United States in spring and early summer. The jet stream instability that produced this 5-day disaster is not an anomaly within the ENSO transition, it is a feature. The window for tornado outbreaks, derechos, and compound weather events is widening as the transition progresses, not closing. Historically, the most violent severe weather seasons in the modern record have occurred during ENSO transition years. The years when the tropical Pacific is shifting between phases and the jet stream is most unsettled. The super outbreak of April 1974, 148 tornadoes in 24 hours, still one of the most violent tornado events in history, occurred during an ENSO transition. The April 2011 outbreak, 362 tornadoes in a single day, the largest single-day tornado count ever recorded, occurred during a La Niña to neutral transition. The atmospheric setup for those events shares a disturbing number of features with the current pattern. A weakened polar vortex, an amplified jet stream, record moisture transport, and an atmosphere in between ENSO states. That does not mean 2026 will produce a super outbreak. It means the conditions that have historically preceded the worst outbreaks are present right now. The 5-day disaster we are living through right now may be a prelude, not a conclusion. The atmospheric ingredients that produced it, record ocean heat, a weakened polar vortex, a transitioning ENSO, and an amplified jet stream, are not temporary. They are not resolving. They are, by every available metric, intensifying. The pattern that collapsed the boundary between seasons this week is the same pattern that will shape the next 3 months. Which brings us to the question this entire video has been building toward, and it is not a comfortable one. Part 16. The boundary between seasons. 296 alerts, 1 storm system, 5 different disasters happening simultaneously across a country that was on fire 5 days ago and is now buried in ice. But the real story is not the storm. The storms will end, the power will be restored, the floodwaters will recede, roads will reopen, the NWS will send survey teams and rate the tornadoes and update the databases, and the event will be archived. That is how weather works. It happens, it passes, the system resets. The real story is that the system may not be resetting anymore. Go back through the data we have covered tonight and look at it not as individual events but as a pattern. 112 degrees Fahrenheit in March, a temperature that has no precedent in the entire history of weather observation for that month. 14 states breaking all-time March records simultaneously. Over 1,500 individual temperature records falling in a single month. The worst fire weather emergency in March history, with language the NWS described as not typically seen for the month. Precautionary power shutoffs in Wyoming to prevent wildfire ignition, in March. Nebraska's worst wildfire in state history, in March. Over 1.4 million acres burned nationally before fire season officially began. Then, 5 days later, 8 ice storm warnings across the upper Midwest, 18 winter storm warnings, a flash flood emergency with 4 feet of water, an estimated dozen tornadoes, 296 simultaneous alerts, 57,500 power outages from ice, 2 deaths, and the extended forecast calling for more. Each of those data points, individually, would be notable. A record March heatwave would make national news on its own. A 5-day severe weather outbreak would be the lead story on every network. An April ice storm after the warmest March on record would generate think pieces and Twitter threads and congressional hearings. But these are not individual data points. They are all happening in the same country, in the same 2-week window, driven by the same atmospheric dynamics. Line up the contributing factors. Global sea surface temperatures at 21.126 degrees Celsius, the highest ever recorded. Arctic sea ice tied for the lowest winter maximum in the satellite record for the second consecutive year. 3 sudden stratospheric warming events in one winter, the most in recent memory, weakening the polar vortex and destabilizing the jet stream. La Niña collapsing toward neutral, leaving the atmosphere without its primary steering mechanism. El Niño loading for summer, promising more disruption ahead. The boundary between seasons was maintained by a stable jet stream, a healthy polar vortex and ocean temperatures within a historical range. Those were the guardrails. The jet stream kept warm air in the south and cold air in the north. The polar vortex kept Arctic air contained. The ocean temperatures set the energy budget for storm systems. For as long as those guardrails held, the transitions between winter and spring and summer were gradual, predictable, and manageable. You could plan a growing season around them. You could design a power grid that expected one type of weather per month. You could run an emergency management agency that prepared for one disaster at a time. All 3 guardrails are weakening. The jet stream is amplified. The polar vortex has been disrupted repeatedly. The oceans are warmer than at any point in the measurement era. And the data suggests this is not a temporary state. It is an accelerating trend. Consider the trajectory. In 2023, global sea surface temperatures spiked to unprecedented levels, and the scientific community struggled to explain the magnitude of the jump. In 2024, those temperatures remained elevated. In 2025, they set new records. And in 2026, they set another record, 21.126 degrees Celsius. Each year is not returning to the prior baseline. Each year is establishing a new, higher baseline. The energy in the system is accumulating, not cycling. The atmospheric volatility that energy produces is accumulating too. Arctic sea ice extent tells the same story. The 2025 maximum was the lowest on record. The 2026 maximum tied it, 2 consecutive years at the lowest level ever measured. The trend line is not ambiguous. It points in one direction, toward less ice, a weaker gradient, a more amplified jet stream, and more frequent whiplash events like the one we just experienced. The polar vortex disruptions are harder to pin to a trend because the sample size is small and the dynamics are complex. But 3 SSW events in one winter is unusual by any standard, and the theoretical framework connecting Arctic warming to increased stratospheric disruption is gaining empirical support with each passing year. The question the data forces us to ask is not whether 2026 is unusual. Of course it is unusual. Anyone who has lived through the last 2 weeks in the central United States can tell you it is unusual without looking at a single chart. The question is whether this is the new baseline, whether 2026 is an outlier, a bad year that we recover from and return to normal, or whether it is the beginning of a new normal in which this level of volatility becomes expected. Whether the atmospheric volatility we're experiencing right now, extreme heat followed immediately by extreme cold, fire followed by ice, drought followed by flooding, all within the same week, is what spring looks like from now on. Not every year, not constantly, but often enough that it stops being an anomaly and starts being a pattern. The answer is uncomfortable. The physics points in one direction. The jet stream will not restabilize while the Arctic continues to warm faster than the rest of the planet. The polar vortex will not become more resilient while stratospheric temperatures continue to fluctuate. The ocean temperatures will not drop while greenhouse gas concentrations continue to rise. Every driver of the volatility we saw this week is trending in the direction of more volatility, not less. If you experienced the March heat wave, and millions of you did, across 14 states, and you are now watching ice storms sweep the same general region 5 days later, you do not need a climate model to tell you something has changed. You can feel it. You felt it when you were running your air conditioning in the late March and wondering why the grass was brown already. You felt it when you saw the fire weather warnings and thought, is this really March? And you are feeling it now, watching snow pile up in Minnesota while tornado watches scroll across your screen for Ohio. The calendar says April, but the weather says everything at once. The transitions that used to take weeks are happening in days, and the extremes on both sides of those transitions are bigger, louder, and more damaging than anything the modern record has seen. The transition between seasons that used to take weeks is now happening in days, and the extremes on both sides of that transition are bigger than anything in the modern record. The data points are accumulating faster than the models can explain them. The atmosphere is behaving as if the boundaries between seasons are dissolving. And the extended outlook, the split flow pattern next week, the heavy rainfall, the continued ENSO transition, says the pattern is not calming down. The boundary between seasons did not just shift this week, it collapsed. And the question is no longer whether it's coming back. The question is what comes next. Because if this is what April looks like, fire and ice and tornadoes and flooding and blizzards, all in the same week, all from the same system, all in a country that was 112 degrees 5 days ago, then what does August look like? What does next winter look like? What does the next ENSO cycle look like? When the El Niño that is loading right now adds even more energy to an atmosphere that is already running at its limits? We started this video with a number. 296, that was the count of weather alerts active across the United States at 7:43 UTC on April 4th, 2026. By the time you finish watching this, that number will have changed, some alerts will have expired, new ones will have been issued, the ice will keep falling in the Upper Peninsula, the floodwaters will keep rising in Ohio, and tomorrow the atmosphere will take another shot at Ohio's biggest cities, with the tornado risk that the SPC has flagged for the Columbus to Cleveland corridor. But the number is not the point. The number was never the point. The point is that 5 days before those 296 alerts, the same country was at 112 degrees, with 8% humidity and power lines being shut off to prevent wildfire. The point is that the atmospheric machinery that's supposed to prevent that kind of reversal, the jet stream, the polar vortex, the ENSO cycle, is all running outside the parameters that defined the last century of weather. The point is that the boundary between seasons, the thing that makes spring feel like spring and winter feel like winter, is not holding anymore. The data says it is not coming back. The extended outlook says more is coming, and the ENSO transition says summer 2026 could make this week look like a warm-up. That is coming, and we will be covering it. Stay tuned.